Given an array and a target, return indices of two numbers that sum to the target. Example, nums, jers 2, 7, 11, 15. Target, jers 9. The answer, indices 0 and 1. Here's a fast ON solution using a hash map. We loop through the array, check if the complement exists, and return the indices. Super efficient!
Given two linked lists representing numbers, add them and return the sum as a linked list. Example, 2 to 4 to 3 plus 5 to 6 to 4 equals 7 to 0 to 8. Here's a simple ON solution using recursion. We iterate through both lists, add corresponding digits, handle carry, and return the result. Given a string, find the longest substring without repeating characters. Example, sliding window expands until repetition occurs, then shrinks. Let's implement an optimized ON solution. We use a set to track unique characters and slide the window efficiently. Given two sorted arrays, find their median in O of log of minimum of m and n time. Example time, we have two arrays, 1, 3, and 2. Let's merge them in sorted order. 1, 2, 3. The middle value, that's 2, the median. Here's how we solve it using binary search on the smaller array. We binary search the smaller array to find the perfect partition. Then calculate median based on total length.
Given a string, return the longest substring that reads the same forwards and backwards. In BABAD, start from the center and expand both ways. BAB is a palindrome, reads same left and right. We use expand around center for every character, O of n squared but fast enough. We expand from the middle and shrink when characters don't match. Keep the longest one we find. Level up your coding game, like subscribe to AlgoSphere.